Okay, data distributions. So here we have, says sports analysts examine data distributions all the time. How many of you seen the movie Moneyball? Anybody? Moneyball. Moneyball. In that movie, Billy Beane, who is the general manager for the Oakland A's back in, I think it was 2001, 2002, you totally went upon statistics to pick his team. And it wasn't based on the biggest sluggers and like that. It was like the ones that they could afford. And so they ended up winning their division in the major leagues because he went and statistically used numbers by different stats to determine who they could afford and who would be the best with who they could afford, and they were actually very successful with that. And if you look at them right now, they actually have one of the best records in the American League right now, and unfortunately Brandon Inge got hurt, and he's not playing for them though. So, all right, so we're going to talk about measures of central tendency, first of all. And when we talk about those measures of central tendency, we're actually talking about mean, median, mode, and range. And later on, we're going to talk about something called the interquartile range, which is a type of range, but it has some different meanings to it. So reminders about them. Okay, the mean is the average. The median is the middle number when you line them up from smallest to largest or largest to smallest. Doesn't matter which direction. Nope, but we're usually going to do smallest to largest. The mode is the one that occurs the most often. Can there be more than one mode? Yes, there can be. Can there be no mode? The answer is yes. If we only have one of every number, there's no mode. Okay? If you have one of every number, there's no mode. Right? And the range is the difference between the largest value and the smallest value. So you just subtract the smallest from the largest to get the range. So, excuse me. When we want to find mean, median, and mode and range, the first thing we'll always do with a set of numbers is we will arrange them from smallest to largest. So the easiest way to get to the median that way. So here, this example represents the number of hours students spent on a research project. And they want us to find the mean, median, mode, and range. And I'm going to give you a symbol that you can use for the mean, so you don't have to write that word out if you don't want to. For the mean, you could actually use this symbol here, which is referred to as X bar. All right, so first thing we're going to do is we're going to arrange them in order. So 2, 4, 5, 7, and 10. And so to find the mean, which we're going to use X bar to represent that, you'll see that lots of times. The mean in this case, so we add them together and divide by 5, and preferably we'll find the total before we divide by 5. Okay, right, Justin? Okay. All right, so what do we got? We got 6 and 5 is 11, 7 is 18, so we have 28 divided by 5, which should be 5.6, right? Okay. The median is the middle number. So we have 5 numbers. And when I put them in order from smallest to largest, the middle number is what? Okay. So what do we do if we have an even number of numbers? Matt, what do you do? You do take the 2 middle numbers, but you find the average of them. Okay? So if you have an even number of numbers, the median is still the middle. So I cut the 2 groups in half, okay? And then take the 2 next to each other in the middle and average them. Okay? The mode, what's the mode in this case? All right, since they're only one of each number, then there is no mode. So we say none. And the range, oops, is the difference from the smallest to the largest. So 10 minus 2 is 8. So we have a mean of 5.6, a median of 5, no mode, and a range of 8. Does everybody remember how to do them then? All right, so you guys do letter B here. Now, a value that is very different from other values in a set is called an outlier. And sometimes when we have outliers, they will make a difference on what piece of data we want to choose to use for our measure of central tendency. For instance, lots of times if we have an outlier, what's affected by that? We have these 4 measures of central tendency: mean, median, mode, and range. Which of those are affected by a number that is way different than the other ones? Okay, Nolan? The mean. Is any other one affected by that? The ranges, okay? The mean and the range are affected by outliers, which means then that changes those values extremely. And so when we're trying to find certain information, sometimes we don't want to use the mean because the mean could be really high because of a number that's much bigger, like this one here, or if it was much smaller than it, okay? Those really affect the mean. So we can see that it pulls the mean away from where most of the data are, and you need to be careful of that. So here we got Rico scored 74, 73, 80, 75, 67, and 55 on 6 history tests. Use the mean, median, mode of his scores to answer each question. So they gave us the mean, median, and the mode there for us already. Which value gives Rico's test average? If we wanted to find his test average, which would you best assume for him? That he's going to get a 70.7 or that he's going to get more like a 73.5? Which one would be a better estimate of his average scores? Okay, right. 73.5, because that one is not affected by this outlier of 55, which is much smaller. So the average of Rico's scores then we would say is 73.5, the median, because it's not affected by that much lower score of 55. Okay. So which value best describes Rico's scores? Which one would best describe? You know what? I just really goofed up, didn't I? Okay, because this says which value gives Rico's test average. That's certainly not the median, is it? I so wanted to write the median that I wrote the median. Okay, this should be 70.7. Sorry. The mean is his test average. But which one best describes Rico's scores? Okay, the median, because the median is closer to most of the scores that he got. You gotta keep an eye on me. Did you catch that mistake? Okay. All right, so you guys do this one. Okay. Now, how many of you remember making box plots or have ever made box plots? Box and whiskers plots. Okay. All right. So box and whiskers plots is one way that they use to help show measures of central tendency. First of all, we're going to take all of our data and we're going to divide it into quartiles, all right, which means we're going to divide it into 4 parts. Okay? Each quartile contains 1/4 of the values in the set. Here we have this other range thing. It's called an interquartile range. The interquartile range is the difference between the upper and lower quartiles, which we call, those are called quartile 3 is the upper quartile, and the quartile 1, or the first quartile, is the lower quartile. Notice how it works. Okay. The first quartile is the bottom quarter of the data, but it actually represents the number that cuts in half. So here's what happens. We find a median. Okay? And then once we found the median, we take the numbers that are below the median and we find the median of them. And that's called the first quartile. We take the upper numbers, or the numbers that are above the median, find the median of those numbers, and that's the third quartile. Okay? So this is really the median of the lower half, and this is the median of the upper half of the data. Okay. So first quartile is the median of the lower half of data. That's all the numbers that are below the median. And the third quartile is the median of the upper half. Okay. The range takes us from smallest to largest, where the interquartile range, the IQR, takes us from the first quartile to the third quartile. So the interquartile range in this case is 4, 7 minus 3, where the range is the largest minus the smallest, or 8. So box and whiskers plot can be used to show how the values in a data set are distributed. Minimum is the least value that is not an outlier. The maximum is the greatest value that's not an outlier. You need 5 values to make a box plot, or a box and whisker plot. The minimum, the first quartile, median, third quartile, and maximum. And over here, right here, they show us mathematically any value that is 1.5 times the IQR less than the first quartile, or 1.5 times the IQR greater than the third quartile, is an outlier. So in other words, the IQR here, or what would make an outlier, is that if we look at this, our IQR in this case is 4, right? Okay. So if we take 1.5 times 4, what do we get? What's 1 times 4? What's half of 4? And 4 plus 2 is 6. Okay, all right. So 1.5 times 4 is 6. Okay. So if we do 3 minus 6, that would be negative 3, right? So any number that's negative 3 or smaller would be an outlier on the bottom half of the graph. And 7 plus 6, which is 13, would be anything 13 or larger would be an outlier on the upper half. Okay, does that make sense? Okay. So we took this is Q1 is the 3, and Q3 is the 7. Okay. So we subtract 1.5 times the IQR to get the smaller one, and add it to the third quartile to get the largest one. Okay. All right. Also, an outlier is represented in a box and whisker plot by a point that is not connected to the box by whiskers. All right. So to make a box and whiskers plot, here we have the number of runs scored by a softball team at 19 games is given. Use the data to make a box and whisker plot. So the first thing we need to do is order the data from smallest to largest. All right, let's see if we can do this. So we have 3. I'm going to put a dot above them when I'm going to use different color. Choose blue. All right, so we have a 3, 4, 2 5s, all right, we have 2 6s, okay, all right, 7 right here, all right, 1 8, all right, then a 9, okay, 3 10s, 1 2 3 10s. All right, we're narrowing them down most of the way there. Okay, we have 11s. All right, 2 of them. All right, bigger than 11, we got, here's a 12, here's a 12, 13, 12, 12, 13. Oops, I missed that one. Okay, and then 15 and 20. Is that right? Okay. All right, hold on here. All right, 15 and 20. All right. Ooh, hey, stay there. All right. So we have 19 numbers, right? Okay. So the first thing we're going to do is we're going to find the median. So we need to find which number then would be the middle number then? If I have 19 numbers, which one's in the middle? Is it the 9th one, the 10th one, the 11th one? Which one would be in the middle? The 10th one would be, right? Because if I choose 10, I have 9 below and 9 above. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, hey, it's a 10. Look at that. All right, so this is the median right here. All right, now to find the first quartile, we take all the numbers below that and find the median of them. Okay, so all the ones below it, we're going to find the median of them. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, which is really nice because then we're going to use the 5th number for that one. So 1, 2, 3, 4, 5. So this 6 would be Q1, the first quartile. Then we find the median of the upper half. 1, 2, 3, 4, 5, which would be the 12 here. That would be the third quartile. And we know our minimum is 3 and our maximum is 20, right? Now, we need to figure out whether 20 is the only one that's really far away, right? And it's really not that far away, but, all right, so we need to establish what the outliers would be. Okay? So here are these two numbers. So these two numbers here determine my IQR. All right? So that is 12 minus 6, which is 6. Okay. So do you think 20 is an outlier? Well, let's see. What's 6 times 1.5? It is 9, because 6 times 1 is 6, and half of 6 is 3. So 6 plus 3 is 9. So 12 plus 9 is 21, isn't it? All right, so 20 is not an outlier, so we're going to include that in it. So here's what we do to make our box plot, our box and whiskers. Right? First thing you have to do is make a number line. Okay? You have to have a number line that incorporates all of our numbers. You can go by 1s, 2s, 3s, 4s, 5s, whatever you want. Does not matter. All right? All that matters is make sure you put things in the right spot. So we make our number line. First thing we're going to do then is we're going to mark the min. We're going to mark all 5 of those spots. Okay? We have the min here, the max here. All right? Q1, median, and Q3. We're going to put dots for all of them. Now, these dots are all going to go above the number line. They do not go on the number line. So I'm going to put a dot here at 3, a dot at 6, a dot at 10, a dot at 12, and a dot at 20. Now, this box plot has a box, right? Okay. The box goes from the first quartile to the third quartile. So I'm going to make a rectangle then that goes from the first quartile to the third quartile. And then where the median is, I'm going to make a line there. And then I'm going to connect these. Oops. Wow, that's not very good. Put them in the middle. These should go in the middle. Right? In some books, when they do it, instead of putting dots on the ends, they actually put a little, they actually put a little line like this. But you can use the dot or the line, whichever one you want. Right? So there's our box plot. Right? It has the min, first quartile, median, third quartile, and the max. Right? How many of you remember making those before? Box plots. All right, good. Okay.